So let's do this presenting scientific data part of the unit. Now, data tables are convenient for organizing data, and to think about it this way, it would be very confusing to put all these cities and all these numbers in a paragraph. So what we do instead is we make a data table where all the similar type of data go on the X. And we call this the manipulated variable because that's the location that we're focusing on. And then the Y, the responding variable, goes over here because this number responds to the number on the left, or excuse me, the city on the left. So that's what a data table will do for us. And it's very convenient in organizing data, but we can continue to make it even more useful by using graphs. Would graph it, one of the things we could use is a line graph. So we would take the data that we had from the previous data and we would think about some things. We'd think about something called slope. And the slope would be important when we're going to look at the steepness of the graph. We have this thing called rise over run, just like from math class, okay? So if we were going to look at the mass versus the volume of water, so this is something different than what we were just talking about with certain cities having certain rainfall, but still it's about water. So if we were going to look at certain data points, we could see that as you increase the mass, you also increase the volume. And we can correspond some things and come up with a definition called direct proportion. A direct proportion, you might want to write that down. A direct proportion means it's going to the right. So when we look at this, that means overall, the trend of the graph is it goes to the right and up, just like this one right here. So we can also say, okay, what if the volume of a cubic centimeter sample is 3? Then we also see that the mass is 3. Likewise, if we take 6, it's 6, and 9, it's 9. This is a very predictable proportion, and it's going up and to the right in a very steady straight line. So that straight line gives us a pretty good idea of how predictable it is. A direct proportion, a relationship between the variables. On the flip side, we could also say, okay, it says the flow rate of a water faucet affects the time required to fill a 1-gallon pot. So what this is a completely different type of line. So flow rate, that means basically how when we turn on the faucet, how much do we turn it on? A little or a lot? So this is the little side, just barely trickle coming out. And then this over here is a full gush, okay? Now, the faster it's coming out, the lower the time value, smaller the time value. If you barely have a trickle, it's going to take a long time. So what we would call this would be an inverse proportion. An inverse proportion would be when, instead of going this way, remember we just said that, we are now talking about when, generally speaking, it goes this way. It goes down, okay? And that is called an inverse proportion. So as one variable increases, the other one decreases, which is opposite of what we just saw on the other one, direct proportion. Now sometimes the data doesn't make sense. So let's take a look at this data table. And there's a lot going on with this, but we can see modem speeds. Now when I first got internet, we had dial-up, which nobody has anymore. Down here is what we're typically used to. And these speeds are probably about right, just a little bit difference between some of them. So this is a lot of data, a lot of words. Let's organize it. If we're going to organize it, we could put it into a line graph. And we can see as we plot these on here that we can see how the data table works as far as data rate versus upload time. Because as we can see here, the higher the data transfer rate, the upload time will be lower. So again, this is an inverse relationship because the big numbers have smaller corresponding numbers. On the flip side, the small numbers have big corresponding numbers, relatively speaking. Okay, so let's take a look at what that means. So how would the doubling the data transfer rate affect the upload time? The nice thing about this is we don't have to do a lot of math. Look at it and, excuse me, I went too fast, but we can just look at it and draw the line. Now back to the question we had at the very beginning about rainfall. The rainfall for each city doesn't make sense to use a line graph. Instead, it makes a lot of sense to use a bar graph right here. Now, bar graphs were popular when you were in elementary. Elementary used bar graphs all the time. And you can see this is kind of nice because we can instantly see Tallahassee was the winner. We can also instantly see San Diego was the lowest amount of rain. So that's kind of nice to have that. And bar graphs are great for organizing when you have words over here and numbers over here. As opposed to the line graph, you have numbers in both X and the Y. So that's a pretty good key point. Circle graphs would work too. These are nice, especially when you're looking at parts of a whole. For example, if we look here at the composition of the Earth's crust, it's pretty nice to have this because we can visually see that oxygen is a huge percentage of the Earth's crust. A bar graph would be nice too, but I like the pie graph because it gives a part of the whole. Lastly, if we look at this, there's all kinds of ways to communicate this data. Communicating this data in this case would be just like if you're communicating information, you could use a conversation, just like you talk to a friend about what you did last night, an email, websites. Sometimes you've been a part of a science fair, but scientists would take these pieces, data tables, line graphs, bar graphs, and circle graphs, and they would use them to show what's going on with their data. We would also peer review, which means I would share my data with people that are doing the same sort of line of work as me, and they would look at it and say, let me repeat that, and let me see if I agree with this or if I have something to add to it too. That's important. Which type of graph is most useful in showing parts of something as it relates to the whole? Well, this is a good one. We just talked about this, and the answer, of course, B, circle graph. Next question. How does a line graph generally show the relationship between the manipulated variable, the x, and the responded variable? Think about that. So it would be A, you're going to plot it on the x, the manipulated, and the variable that is responding on the y. That's generally how we always do it. Number 3, how do scientists communicate the results of scientific investigations? There's a few on there that make sense, and a few that don't make sense, excuse me. It'd be A, by writing a scientific journal or speaking. Only is kind of a tricky one. Literary journals we typically don't do in science. Why is a peer review an important part of the scientific process? Like anything, it helps to find errors, it can identify bias in research, or anything like that. So, again, some review here, but also some good ways to focus on things that are important in communication with science.